Hi, today I'll be showing you Algvis, an educational tool that can help users visualize many common algorithms. This is a home screen. You can see there's a nice welcome message here. You have three options to go to Algorithms, Options, or Tutorial. So the main place that a new user might go is Tutorial. This will explain everything you need to know about the solution. So this one's quite self-explanatory. To enter the visualization screen, you click Algorithms, and algorithm you want to visualize. So what's important about the tutorial is that it builds upon each stage, and each button won't have an effect on the main solution. So I can press this, but nothing's happening. You can get a sense of what you need to do to navigate the main solution. So these are some options that you can find in the options menu. I'll go over this later. You can toggle these on, so green means on, red means off, and this will change what is shown on the main visualization screen. But as these are just tutorial, this is just a tutorial, these won't actually matter. It's just to help you get a sense of how you would change these things in the main options menu. This is the same for this. You can practice using the widgets. You can enter some data. It'll tell you if it's correct or not. So this is in the correct format. If you type in just gibberish, it will tell you how to do it. So to view the algorithm you selected, when you click the algorithm select screen, you can click the play button and watch a visualization. So here you can press it and it will show you that your input's been read. All the bars go blue to show you that your input's been received successfully. You can still enter your own data here. So it's gently building up your knowledge how to use a solution. And then here is some extra information that will be shown on the visualization screen that you'll see later. And you can toggle this on in the options as well. Okay, so if you go back, I'll show you the options now. It's just like in the tutorial. You got labels and you can turn them on and off. And then each of these will change what is shown in the main solution. So let's see if we have them all on and we go here, you will see the O and time complexity is shown, as well as the description of why it is what it is. If you just start the algorithm quickly, you can see that it's showing you how the process is working, and it will show that if we turn it down, it will tell you that live. This is quite basic here because it's bubble sorts, but other algorithms have more complex processes and they will all be explained. And you can turn, so say we want to turn some of these off, say we only want live process to display, it will not show you the ON, but it will show you the live process display is shown. So if you're a student and you want to test yourself and you want to turn it off and you want to go in and try and remember, then you can. Similarly, if you're a teacher, say you want to show them a new algorithm, but you want them to sort of try and infer what the ON complexity was, you can do that. So that's quite helpful. Let's turn it on for now. So here is the algorithm select screen. You've probably seen a bit already. And so clicking each of these buttons will load a different sidebar here. It will tell you the name of the algorithm, and it will give you a short description of what it is and what it does. So linear search is a search algorithm that checks each element in a list sequentially and it queries whether it is the same as a search value and returning it if it's true. It's the same for all of these. You can read them if you want. Fortunately, I didn't get onto some pathfinding, but I hope to add that in the future. Okay, so onto some searches. I'll show you linear search. So this can be quite a lot to take in, but hopefully the tutorial will help you if you need it. So here, you've got the sidebar here. You can click back to go back. You click play, then You enter in your search value and it will go. You can change the speed if you want. You can enter your own data. So say you want to type in 5396 for example. You can search for 3. There you go. You can also enter random data. So it really is quite powerful what you can do and what the limits are with this. You can change a lot of options about it. You also got the key here, so say you don't understand what it means by red, then it will say it's a pointer. So you can imagine a pointer going for each of these to the next, checking if it's an element, and say you're looking for a piece of data that doesn't exist in a list, so say 7. It will go through, and it will go red just to show that the element hasn't been found. And if it's green, the element has been found. And the key will tell you this. Binary search also works. If you want to add some more data, maybe, and say you're looking for the element 3, you can see here it will sort the list, discard the larger half, check the next element. If it doesn't find it, it will go red. So there you have the data 5, and then you want to search for the element 3 again. You can do that. As you can see, it works as binary search does, and the key is still the same, and code execution will show you what's happening. So hopefully you can gain a sense of what the algorithm is doing, and that will help you in your exams or learning the algorithm or whatever. Okay, so bubble sort, it's quite similar, but it will sort each bar instead of just highlighting it. So as you can see, it will move them up out of the list and then sort them, and swap them, sorry. The key will show you what the colours mean, so the bar swapping is in blue, and when it's completed, you turn this up to the maximum, and we'll go green. Our code execution again tells you the ON is different than your search, you might have noticed, and this is it will show you the ON and the description specifically for each algorithm. You can also enter your own data here, works as before. Yeah, I'll show you the rest of the sorts. So, insertion sorts. As you can see, it's working as insertion does. It has a sorted portion of the list, and then moves each element that isn't sorted into the sorted portion. As you can see, hopefully this will help you to get a better understanding of the algorithm. Okay. Merge sorts. This you might notice, has an extra key option called pointer, and it's kind of like in the searching algorithms, it will show you an important piece of information that the algorithm is using. So in this case, the pointer is showing the start and end of the 2 sublists. So start and then as it merges them, it will move those into the correct order. This is easier to see when it moves like larger lists together, although you can see it at any point, as you can see there. So this is a start and end, start and end. You get the idea. And so if you get an exam question being like, how are the pointers used, then you can use this and it will help you answer it. Quick sorts. It uses a pointer and moves everything that's smaller than it to one side and everything that's larger than it to the other. And you can see this process in the algorithm. So put on 5, just be a bit quicker. You can also see here that the way quicksort works is it will move everything and then move itself once it's gone through the list. This is also shown. This will also help you. See the process execution is getting a bit more complicated, but it will still show you what exactly is happening. And now we go on to radix sort, which isn't as common as the rest, but I still think it's an important algorithm, and it's probably one of my favourites. Okay, so it works slightly differently, and it has its own visualization method to compensate. So the way it works is it will check the last digits and put it in its own bucket. So say 2609 will go into bucket 9, and then it will keep going through all the more significant digits, so 9 and 0 and 6 and 2, getting more significant as it goes. And yeah, the key is slightly different. So you've got blue for the element that's being moved into or out of the bucket. It goes green at the end when it's completed. And what you may see here is it's got a list of all the different digits, and it will show you the specific one that's being looked at when placing it in the bucket. So say this is the last digit. So it will move from here into the bucket, it will go down and place it down. When it's moving it out, we'll move it up and then back into the list here. As you can see, it's working. It's now 2. This is the third digit in the number it's looking at, and you can see its overall process. So if you're learning this algorithm for the first time, hopefully this tool could help you. Make it a bit faster. And now you can see it's in the correct order. Okay, so that has been a demonstration. Thanks for watching. Hopefully you can see that it's quite powerful in what you can do, and there's a lot of variation you can do with the data, all the options you use that will hopefully help your learning and help you to achieve whatever you want, be it getting higher exam scores or helping your students learn the algorithms better, whatever you want. So thank you for watching. If you can, please can you fill out the form that has been sent alongside this video. It will greatly help me with my NEA. Thank you.